Alright, boys and girls, ladies and gentlemen, dogs and cats, mice and men, welcome to our second video lesson in Chapter 11 as we continue our quest into the understanding of limits. Here we go. Okay, our second method for evaluating limits is called the dividing out technique, or factor and cancel. Okay, as we look right here, we're going to find the limit of this function. So our f of x is x minus 5 over 25 minus x squared. And we're going to find that limit as x gets closer and closer to 5. Let's try direct substitution first. If I do direct substitution, I'm going to get 5 minus 5 over 25 minus 5 squared, which is 25. So you see now we have 5 minus 5 is 0 over 25 minus 25, which is 0. 0 over 0 is one of our undefined terms. It may or may not have a limit, but it certainly does not exist when x equals 5. The function does not exist when x equals 5. So let's do we could not directly substitute because we get 0 over 0. So let's do our dividing out technique right now. What we're going to do is we're going to factor both top and bottom. So I'm going to factor the top, which is done. It's x minus 5. I'm going to factor the bottom. I get 5 minus x times 5 plus x. That is a difference of squares. I'm actually now going to divide a negative 1 out of the top. So I have negative 1 times negative x plus 5, which of course is 5 minus x. So I can cancel the 5 minus x with the 5 minus x, and I'm now left with negative 1 over x plus 5. If I do direct substitution now, if I plug in 5 for x, I get negative 1 over 5 plus 5, which is 10. So my limit is negative 1/10. And that is my answer. Okay, let's try this guy right here. We're going to use our third method now, which is called rationalizing, or looking for conjugates. If I try direct substitution right now, if I let x be 0 in both top and bottom of my function, I'm going to get 7 minus 0, which is 7. So I'm going to have root 7 minus root 7 over, when x is 0, I get 0, which means now I have 0 over 0. That again is our undefined term, 0 over 0. That does not exist. So we're going to try to do something else. I can see a chance to multiply by a conjugate up top. So I'm going to multiply both top and bottom of my function by root 7 minus x plus root 7. Both top and bottom. So that's root 7 minus x plus root 7. Notice now I have conjugates up top. So I have basically a minus b times a plus b, which is a squared minus b squared. So up top now I'm going to get radical 7 minus x squared minus radical 7 squared over x times root 7 minus x plus root 7. So up top, when I square those radicals, I just end up with what's inside the radical. So I'm going to get 7 minus x minus 7 over x times radical 7 minus x plus 7. Up top, you can see now I get 7 minus x minus 7, which is now just negative x. Let me switch colors. So the 7's go away. I'm left with negative x. I can cancel these x's. So I'm left with negative 1 over root 7 minus x plus root 7. Well, when x goes to 0, I'm going to get root 7 plus root 7. So my final answer is going to be negative 1 over 2 root 7, which we know we can rationalize. Multiply both top and bottom by root 7. I'm running out of room here. Root 7, root 7. And that's going to give me an answer of, I'll write that up top in purple so we can see it, negative root 7 over 2 times root 7, which is 14. And there is my limit. Okay, let's try this guy right here. I'm going to take the limit of the function of 1 minus sine over x over cosine x. The limit as x goes to pi over 2. If you remember, pi over 2 is about 90. Okay. If I try direct substitution, 1 minus sine x, well, sine of 90 is 1, so I have 1 minus 1 up top, and the cosine of 90 is 0. So 1 minus 1 is 0. 0 is 0. Hey. Once again, I got 0 over 0, which is my undefined term. I'm going to multiply by a conjugate, both up top and down below. I'm going to multiply by the conjugate of 1 minus sine x, which is 1 plus sine x. So in essence, I'm now going to have 1 minus sine x over cosine x times 1 plus sine x over 1 plus sine x. Up top, those are conjugates, so I'm going to have 1 minus sine squared. On the bottom, I have cosine times 1 plus sine. Okay, if you remember, 1 minus sine squared is equal to cosine squared. So I can cancel a cosine from both top and bottom. So I'm going to have cosine over 1 plus sine. And now let's plug in our x equals pi over 2, or x equals 90. Well, cosine of 90 is 0. Sine of 90 is 1, so I have 1 plus 1. So I have 0 over 2, which of course equals 0. So our limit is 0. Okay, let's look at this guy right here. We're going to talk about some one-sided limits. If I try to direct substitute, as x approaches 2 of the absolute value of x minus 2 over x minus 2, okay, if I plug in x equals 2, I'm going to get the absolute value of 2 minus 2, which is 0. 0 over 2 minus 2, which is 0. Notice I have 0 over 0, my undefined term. Okay, let's just look at the calc for a minute. Plug this into the calc. We can see in the graph now, as x gets closer and closer to 2 from the negative side, our value is negative 1. As x gets closer and closer to 2, it approaches 2 from the positive side. The value of our function is 1. As we look at the table, we can see as x gets closer and closer to 2 from the negative side, our values of our functions is 1. At 2, it's an error, it's undefined. And as x gets closer and closer, it approaches 2 from the positive side, we have 1. So the limit here does not exist because from the positive side, our limit is positive 1. And from the negative side, our limit is negative 1. This limit does not exist because the limit is approaching different values from both the positive side and the negative side. If I were to just take the positive limit, though, so if I wrote the limit as x goes to 2, positive side, that's the notation of that, that would equal 1. While, likewise, if the limit as x gets closer to 2 from the negative side, the notation of that is negative 1. Both of those one-sided limits do exist, However, because they approach different numbers, then the limit itself does not exist. Okay, this is muy importante, the difference quotient, and we will talk about this in 11-3. You level 1 kids, you have seen this before, way back in the beginning of the year, but we're going to be doing some algebra now. We're going to find the limit of f of x plus h minus f of x as h goes to 0 all over h. So let's try one and see what happens. So let's find the limit of the function f of x minus 6, that's my function, as the limit as h goes to 0 of f of x plus h minus f of x all over h. So in other words, what we're going to do is we are going to plug in into the function f of x minus 6, f of x plus h, and f of x. So up top, what I'm going to have here is I'm going to have f of x plus h is 5 times x, but now it's x plus h, minus 6, minus f of x. Well, f of x is 5x minus 6 all over h. The limit of that as h goes to 0. Well, let's do some simping up top. Do you see I can multiply 5 times x, I can distribute, plus 5h minus 6 minus 5x plus 6 when I distribute my neg. Well, that equals, the x's are going to cancel, 5x and 5x. The 6's are going to cancel. So I have 5h all over h as h goes to 0. Quite nicely now, my h's cancel. So I have 5. So the limit of this as h goes to 0 is 5. Let's try one more. Find the limit, the difference quotient, as h goes to 0 of f of x plus h minus f of x all over h, where our function is root x minus 2. So what I'm going to do here is I'm going to plug in x plus h into f of x. So I'm going to have radical x plus h minus 2 minus f of x, which is radical x minus 2 all over h. And of course, as h goes to 0, we're going to get 0 over 0. Okay, so we already know it's an undefined term, but I'm going to subtract. I'm going to erase that for a minute. And here we're going to multiply by the conjugate, both up top and down below. So we're going to multiply by root x plus h minus 2 plus root x minus 2, both top and bottom. So root x plus h minus 2, that's all inside the rad, plus root x minus 2. Okay, now when we multiply up top, I know once again I get the radical squared, so I'm going to have radical x plus h minus 2 squared minus radical x minus 2 squared all over h times radical x, that was too much, hold up, whoop, radical x plus h minus 2 plus radical x minus 2. If I square those radicals, I just guess what's inside the radical. So I have x plus h minus 2 minus x plus 2 when I distribute my neg all over h times, once again, my radicals, x plus h minus 2 plus radical x minus 2. Okay, up top we can now see my x's are going to go, my 2's are going to go. That leaves me with an h, both top and bottom, so I'm going to cancel those h's. So I'm left with 1 up top over radical x plus h minus 2 plus radical x minus 2. Well, as h goes to 0, this h becomes 0. So I have 1 over 2 root x minus 2. And once again, I'm going to just rationalize. So I have a radical x minus 2 over 2 times x minus 2. And I'm done. All right, folks, that's it. We'll see you soon, and we will go over these in class. I know this is hard. Let's just use this video as a resource.